Good morning, grade 7s. Welcome to your mathematics lessons for today, brought to you by WorksheetCloud. I hope you guys are well. Just a reminder about the email address on your screen. Please feel free to use it and send me any queries relating to any maths content that you'd like me to cover or clarify. Okay, let's get on with today's lesson. So today we're going to be looking at interior and exterior angles of polygons. So we'll be staying with the geometry theme, and it's something new that you might have touched on in grade 6, but we'll take it a little bit further today. And then your normal warm-ups and finishes on either side of that. Okay guys, so quite a few slides to get through today, so let's get into our warm-up straight away. I think this warm-up's one of the trickier ones we've done. It took me a while to figure it out. So let's see how you guys get on. So I first looked at the third line and I reminded myself about order of operations. So I needed to do 2 divided by 5 first, which is the same as 2/5. So what multiplied by 2/5 is going to give me 20, and I worked that out to be 50. Okay, so if we'd like to prove that, I can do so. So if I said 50 over 1 multiplied by 2/5, that's pretty much what we got, okay, because this here is 2 divided by 5, okay, then I can go 50 multiplied by 2 is 100, and 100 divided by 5 is 20, okay, so that's where I would have started, okay, so that was okay. And then I went and I put in 50 for the Eiffel Tower wherever it belonged. And I knew that that was also going to be 50 plus 5, which is 55. Okay. I then went and did a little bit of trial and error to see how things would work out. And I ended up with the following. And the Golden Gate Bridge was 7. And the Opera House also worked, the Sydney Opera House also worked out to be 50. That's the Sydney Opera House there. Okay, so Golden Gate Bridge in San Francisco is 7. The Sydney Opera House next to it is 50. And then the Eiffel Tower in Paris is also 50. Okay, so that means that the Colosseum, which is in Rome, needs to be 5. Because those two sides need to be equal. Okay, then I know that the Golden Gate Bridge was 7 plus the 5 minus 4 is equal to 8, and let's check that. 7 plus 5 is 12, minus 4 is 8, not 18. Okay, and then at the bottom it's again 7 minus 5 in brackets plus 50 multiplied by 50. And we do the brackets first, and that gives us 2 plus 2,500. Okay, and you will get an answer of 2,502. Okay, so as I said, I went through that a couple times and plugged numbers in. I might have just been missing something, but well done if you worked through that and got 2,502 at the end. Okay, your mental questions for today, okay, are the following. Go work them out. They're based on past principles, and then press play to see how you got on. 30 Rand deposit on a carpet costing 150 Rand. How much more money did he have to pay? So I must first work out the deposit, and 30% of 150 Rand, so 10% is 15. So 30% is going to equal 45 Rand. So he's paid 45 Rand. He still needs to pay 105, and then he would have paid 150 for the carpet. All right. So remember there are 2 parts to the question there. First working out the percentage deposit, and then how much left he is due to pay. All right. Question 2. Complementary angles add up to 90 degrees. Okay, so that's like your right angle, angles that add up to 90 degrees. and then supplementary angles add up to 180 degrees, and those are your co-interior angles, angles on a straight line. Those are two examples of supplementary angles. Okay, so it's just good to know those two things. Then which of these fractions are equal to 12.5% and 33,3? So a few lessons ago I gave you a table where I said, look, it's really important to know certain fractions, decimals and percentages. And for me, you should know that 1/8 equals 0,125, which is 12.5%. Okay, you should just know that. And that's going to make your life a lot easier when you're dealing with eighths. Okay, and then you should also know that 1/3 is equal to 0,33 recurring, which is 33,3%. Okay, so know those. Go back and look at that table that I gave to you and that we spoke through, and make sure you understand those fractions, decimals, percentages, conversions. Okay, we've got a distance, speed, and time question for number 4. So number 4 says 700 kilometers from PE to Cape Town, Port Elizabeth. Find the nearest hour, the time taken by a truck, if the average speed was 60 kilometers in an hour. So 60 kilometers in an hour. Okay, so 60 kilometers in 60 minutes. All right, so I need to find out 700 kilometers. So the first thing I'm going to do is say, okay, well, from 60 to 600 is multiplied by 10. All right, so that means I can do 600 kilometers in 600 minutes. Okay, let's put an M there for minutes. All right, so then I know that 660 kilometers will be 660 minutes. Okay, how long is 660 minutes? That's 11 hours. Okay, there are 40 minutes left over, so that's 40 minutes over 60 minutes. And the question says the nearest hour. Okay, so it's over 11.5 hours, so therefore I'm looking at 12 hours traveling time. Okay, so that's one way you could have done it. You could have recognized the numbers and worked through it. If you had gone, you could have also gone and said, look, if he does 60 kilometers in 60 minutes, okay, how far does he go in 10 minutes? He goes 6 kilometers in 10 minutes. And then you could have gone and multiplied by 100 to get the 600 kilometers in 600 minutes, and then recognize that you could have added on another 60, and then there was a remainder of 40 kilometers. Okay, so you had a couple of options there, but your answer should have been 12 hours. So if you had left your answer as 11 hours and 40 minutes, it's not entirely correct, because the question asks you find to the nearest hour. Okay. And then question 5, which is a better bar per kilogram? 5 kilograms at 75 Rand, okay, or 1,250 grams at 20 Rand, okay, and you could have recognized that 1,250 grams multiplied by 4 is going to give you your 5 kilograms, which is 5,000 grams. That means I must multiply 20 Rand by 4, and that gives me 80 Rand. Okay, and now you can compare because you've got equal amounts. So you can see the 5 kilograms costing 75 Rand is the cheapest. So you've already worked out the first part of the question, and the second part of the question is by how much, and that's by 5 Rand. Okay, so be aware of when there's 2 things expected of you per question. Okay, well done if you work through those. Okay, so we're going to get on to our main part of our lesson today, and that is polygons. Okay, so the first thing we need to just remind ourselves is different types of polygons and their names. And I'm pretty sure that you guys will be aware of the names of these polygons according to their number of sides. So that's just a little bit of a refresher for you. If you don't remember, you can always go back and have a look. Okay. So let's talk about exterior angles in polygons. All right. So at the moment on the screen, you've got a triangle that has only got interior angles, and we know that the interior angles of a triangle add up to 180. But if I extend the sides of the triangle, now all of a sudden I've got exterior angles. Okay, and those are the exterior angles on your screen right now, D, E, and F. So how do we work out the sizes of those angles? Well, an exterior angle in a triangle is equal to the sum of the opposite two interior angles. Now that's quite a mouthful of words. So basically what that means, and if you look on your screen now, is A, so the exterior angle A is equal to B plus C. Okay, and that's for every triangle. All right, so I'll tell you again that the exterior angle A is equal to the opposite two interior angles added together, so B plus C. So we can prove this by constructing a parallel line to that side that's just been drawn. And now you should be able to see an alternate angle. So you should see a Z angle which makes C and A equal. Okay, and that would be alternate angle. And then you should be able to see an F angle that will make B and B equal. Okay, so almost like an upside down F. Okay, so therefore B plus C on the right hand side of the diagram will equal B plus C on the left hand side of the diagram. Okay, so that's interior and exterior angles of a triangle. Why don't you guys go and see if you can work out the values of those angles that are identified by small letters on your screen right now. Okay guys, so you've been given an exterior angle of 64 and one opposite interior angle, and we know from the previous slide that A plus 31 must equal 64, so therefore A must equal 33 degrees. For B, I've got an exterior angle in B. I've got 82 and 34 as the opposite two interior angles. If I add those together, I get 116, and my angle size of B is going to be 116. For C, I've got an external 131 degree angle. They've also given me a reflex angle of 272. So first I need to go work out what that internal angle with the 272 reflex angle will be, and I know that angles around a point are 360 degrees. So I need to know how much further is it from 272 to 360, and yes, that's going to be 88 degrees. Okay, so one of my opposite interior angles is 88. What do I add to 88 to get to 131? Because that's what's going to be my angle C. Okay, and that's going to be 43 degrees. All right, so angle C is going to be 43 degrees. So important there to work out the internal angle next to the reflex angle first, which is 360 minus 272, okay, which is going to give you 88. And then from that 88, what do I add to the 88 to get to 131? And that's going to be 43. And then for D, I've got 152 as an external angle. They've given me 127 as one of the opposite interior angles. What do I add to 127 to get to 52? And that's going to be 25 degrees. Okay? All right, and there they are for you on your screen. Okay, so here's an interesting problem for you to try out. You need to calculate the size of the lettered angles in the diagram. Let's see if you can make the most of those clues that you got in front of you. I'll give you, or take as much time as you want, and press play when you want to see how you've done. Okay, so I'm going to carry on now. The first thing I'm going to have a look at is I'm going to identify that there's an isosceles triangle on the screen in front of you, indicated by the two stripes on the triangle showing that they are identical lengths. So I know the angles of a triangle add up to 180, so therefore 180 minus 104 is going to give me 76, and 76 divided by 2 is going to give me 38 degrees. Okay, so those two angles are going to be 38 degrees based on the angle properties of an isosceles triangle. Okay, from there, I know that angles on a straight line add up to 180. So angle A will be 56 plus A plus 38 must equal 180. And if I go work that out, A is going to be 86. Okay, and B is the same. 38 plus B plus 73 must be 180. So therefore, once I subtract 38 and 73 from 180, I get 69 degrees. And now I've filled in the angles that I need to know. So that brings us to interior angles of polygons. This is the second take I've had to do of this, so let's hope I get it right. Just a little bit of a technical issue. So we know that polygons have different number of sides. The polygons on your screen at the moment are irregular, meaning that not all the sides and all the angles are equal, as they are in regular polygons. So they're the names that we've been through already. And in each of these polygons, I can make triangles. So in a quadrilateral, I can make two triangles, and we know the angles in a triangle add up to 180 degrees. So therefore, the angles in a quadrilateral must be 2 times 180, which is 360. In a pentagon, I can make three triangles. Each triangle is 180 degree each. So my interior angles of a pentagon must be 540. For a hexagon, 4 triangles. And 4 times 180 is 720. So that's the size of the interior angles of a hexagon added together. And in a heptagon or septagon, it's 5 triangles, and 5 times 180 is 900. So there is a little bit of a link between the number of sides of a polygon and the number of triangles that you can make in that polygon. And you're quite correct if you had noticed that you subtract 2 from the number of sides to get to the number of triangles. So 4 minus 2 is 2 for quadrilaterals, 5 minus 3 is 2, 5 minus 2 is 3 for pentagons. For hexagons, 6 minus 2 is 4, and for septagons or heptagons, 7 minus 2 is 5. So for an octagon, you'd be able to make 6 triangles, 8 minus 2. For a nonagon, 7 triangles, 9 minus 2, and a decagon, 8 triangles, 10 minus 2. So what you might see is we would say that a polygon of n sides, you'd have to subtract 2 from that to get the number of triangles, okay, where n is the number of sides. Okay, so there's the formula there, and the n is just representing the number of sides. So here are a couple for you to do, or I'll work through these with you, and then I'll give you some to do by yourself. So you know that in a quadrilateral, and I've just explained that the interior angles are adding up to 360. They've given you 245 of those degrees with the 3 angles shown, so we just subtract from 360, and W is 115. For the pentagon, we know it's 540 degrees. 395 degrees has been given to us. So to work x out, we just subtract 395 from 540 and we get 145. For the hexagon, it's 720 degrees. Subtract the degrees given, which is 603, and that leaves you with y being 117. And z you work out similarly, and you get an answer of 124. Okay, let's see if you guys can go work these ones out for yourself. Press play to see how you get on. First one is a hexagon. Hexagon is 6 sides, minus 2 is 4. 4 times 180 is 720. Subtract the angles that has been given to you, and you're left with y equaling 125. The pentagon, or irregular pentagon, in number 2, the missing angle x works out to 122. The quadrilateral in number 3, you needed to recognize the right angle represented by the black square. That would have left W being 120. And in question number 4, Z is going to be 120 degrees as well. Guys, important for you to go over that and make sure you understand that concept. Replay it, practice it again, and make sure that you know what's going on here. Okay, so interior angles in a polygon, and this is just a bit of a recap for you. So we know that the number of triangles that a polygon can be divided into is always 2 less than the number of sides. So that's where your n minus 2 comes from. And we know we must multiply n minus 2 by 180. So again, guys, the n stands for the number of sides that that polygon has. So if it was a triangle, n equals 3. If it was a quadrilateral, n equals 4. Pentagon, n equals 5. Etc., etc. Okay, and this is just a little table for you on regular polygons. So you know, regular polygons, all angles are equal, all sides are the same. So that is what your angles in your regular polygons are going to add up to. So your pentagon, you know it's 540 due to the 3 triangles. You know that there are 5 angles in a pentagon. All of them are equal, so they're 108. Hexagon, very similar. This time it's 4 triangles. Multiply that by 180, you get 720. Hexagon has 6 angles, and because they're regular, they're all equal. So it's 720 divided by 6, which is 120. Okay, and then just some interior and exterior angles in an equilateral triangle. We know the interior angles are 60. If we extend the lines, we can then see that the external angles or exterior angles are 120. If you add all the interior angles together, you get 180. If you add the exterior angles together, you get 360. So if I do squash that triangle, I will get angles around a point equaling 360 degrees. It's a square. All the interior angles measure 90. So all the exterior angles measure 90, and again, the sum of the exterior angles is 360, same as the equilateral triangle. And again, if I squash that square, I should have angles around a point equaling 360 degrees. In a pentagon, we've worked out that the interior angles are 108. If we extend the lines, we get 72, and again, the exterior angles add up to 360, okay? And the same thing applies. If I had to squash that pentagon so that all the 108 degree angles disappeared, then I'd be left with angles around a point equaling 360 degrees. And then just with the hexagon, we worked out that the internal angles or interior angles are 120, so the exterior angles must be 60. And yes, you're quite correct if you had said the exterior angles are again going to add to 360. And that's going to be the same for all regular polygons. Okay, guys, so that just leaves us with our 24 challenge for you to do today. By now, you should know that you need to use all 4 numbers on each card to get to a total of 24. You can use add, subtract, multiply, divide. You can use one of them, 2 of them, all of them. See how many different ways you can get to the answer of 24. And I trust that you're challenging someone at home, and hopefully some of the chores that you're supposed to do at home you can give to someone else as a forfeit. Grade 7s, thanks very much for watching today. Please go look at your online activity with Memo. There's some nice stuff there for you to practice and to just consolidate the ideas that we've learned today. Have a great day, and I look forward to seeing you again soon. All the best.